Hello everyone. In previous video lecture, I have covered the topic format of symbol table and representation of symbol table. Today we will discuss the operation on symbol table. Four major operations are performed on symbol table. First is insert. If any information about variable, function, class, object to be inserted in symbol table, it can be written as insert a, integer. A is the name of a variable and its type is integer. Next operation is lookup. This operation will be written as lookup symbol. It means if we write lookup A, then it will fetch all the information of A such that A is a variable and its type is integer. Next operation is delete. The delete operation will be written as delete symbol. The symbol you want to delete will be written here. So here I write delete A. So this operation will delete all the information of A from the symbol table. Next operation is scope management. In any program segment, some variable or functions can be a global or local. Scope management will manage its scope. Now, take an example of this C code. You can see in this program, the variable value is initialized globally. This code is a good example of scope management. In this code, I have taken two functions, 1 and 2. And the scope of the function 1 is from here to here and the scope of the function 2 is from here to here. So inside the function 1, we have the another scope for the variable C and D that comes inside the variable integer A and B. And there is another scope inside the function 1 is for variable F and G that comes inside the variable E. Similar for the function 2, inside this function 2 is the another scope for the variable P and Q that comes inside the variable X and Y. Now we create a symbol table for this code. First symbol table we will have to make for global variable and functions. In this code, value is a global variable and 1 and 2 are the functions. You can see these entry in the symbol table that we made for global variable and function. First we take value. It is a global variable. It is a variable, so we write here var and it is of type integer. 1 is the name of a function. It is a procedure, so we put procedure here and it is of type void. Same for the function 2. Function 2 is a function, so we put here the procedure and its type is void. So if we see the code, the function 1 and the function 2 have many variable declaration. So we have to make a link for global symbol table for the function 1 and for the function 2 and fill the entries in the symbol table. You can see this link for the function 1 and the variable inside the function 1 are A, B and E. So A is a variable and it is of type integer. B is also a variable. It is of type integer. E is also a variable and it is of type integer. So this symbol table entry is for function 1. Now we write entry for the function 2. So we have the variable X. It is a variable and type integer. Next, the variable Y, and it is also of type integer. Next, we take the variable R, and it is also of type integer. The next topic is implementation of symbol table. There are multiple ways of implementing symbol table. The first method is linear search organization. The simplest way of implement a symbol table is as a linear list of records where each record describes one word. Normally an array is used to store information. The symbols exist in the table in their order of arrival and are not sorted. The list is always searched from the last to first record in the sequential manner. It means if there are n entries in the table, on the average, we search n by 2 names for successful search and n names for an unsuccessful search. Therefore, a search takes time proportional to n. You can see from this table, here I define the two fields, name and attribute. Name means the name of the symbol and attributes means information regarding that symbol. The insertion operation is done through this available pointer. The drawback of this linear search organization is, for a large program, the time required to search any symbol is large. It means the time spent to either locate a symbol or to conclude that it does not exist in the symbol table is large, because the symbols are stored according to their arrival sequence. The next method is self-organizing list. This symbol table implemented using linked list. In this list, a link field is added to each record. It means you can see from this table, we have mentioned 3 fields: name, attribute and link. And we have given the name of symbol, attribute means information regarding that symbol, and link means the link or the pointer to that symbol. The self-organizing list first see the occurrence of variable or the symbol and set the priority. Suppose in a program ID4 is used multiple times, so ID4 will be on higher priority and the next link to this ID4 will be on the second priority. So here you can see I connected ID4 to the ID2, then ID2 is connected to ID1 and this ID1 is connected to ID3. If a new symbol is added to the symbol table, so the self-organizing list organizes itself accordingly to the occurrence of new symbol and reorganize its structure. The drawback of this self-organizing list is it requires extra time to reorganize itself whenever a new symbol is added. Next method is binary search organization. If we store the symbol in alphabetical order, we can reduce the search time by using binary search method. In this method, the table is successively divided into 2 subtables. This division into 2 subtables is achieved by comparing the incoming symbol with the middle entry of the table. So normally the insertion of symbol in this search method is same as insertion in binary search tree. Means the symbol greater than the root is placed at the right hand side and the smaller symbol will be placed in the left hand side. So if we choose ID 1 as a root, so we can see from the above table the occurrence of ID 4 is higher, so it will be placed on the right hand side of the ID 1. Similarly, the occurrence of ID 3 is less than the ID 1, so this will place at the left hand side of ID 1. The occurrence of ID 2 is higher than the ID 1, but it is lesser than the ID 4. So it will be placed as a left child of ID 4. The method that takes the least time to search a symbol is considered the best. So, next method is hash table method. Hashing is most powerful implementation technique in symbol table. In hashing scheme, two tables are maintained. Here, the two tables are formed, hash table and symbol table. The symbol table is like the self-organizing list. As you can see the symbol table here, the two fields name and attribute are present and they are linked by one another. The second table, that is a hash table, and the name part of the symbol table is taken in the hash table, and we index the hash table from 0 to k-1. Now we apply hash function to it. So as soon as we apply hash function, it returns an integer value and it will come to the directive search. Both the table are linked together through pointer. So if I apply hash function on j, means h on j, it will return integer value 2 and information of j will be accessed. So in this way hash function works. Insertion operation is done through the available pointer. So if we talk about the searching, then faster searching will be in the hash table method. Next will take less time in binary search tree method, and next will take less time in self-organizing list or in linear search method. In the next lecture, we will cover some other important topic. Thank you.